All right, we're going to look at some other problems that will help us prepare for our midterm on sections 1 and 2. So let's look at this polynomial function. So this polynomial function is in factored form. So it's asking what is the degree. So the degree, remember, is how many factors you have when it's in factored form. So if I look at this, there are 4 factors here, and 1 factor here, and 3 factors here. Now the 5 out front is leading coefficient. It doesn't have an x or anything, so it doesn't really count as a factor. So there are 8 factors, so we're degree 8. Now in general it says determine the end behavior, but I'm going to leave that. Typically this is better to do after you graph it. So I'm going to wait until I get through D, and then I'll go ahead and I will graph it. And then I'll talk about the end behavior. So let's find the zeros and the multiplicities. So the zeros are what makes each of these factors 0. So my zeros are going to be 7, 4, and negative 5, because that's what makes each of those individual factors 0. The multiplicity is how many of each of those have. So for 7, I have 4 factors of 7, so my multiplicity is 4. And what that's going to do is that means this is going to touch when I graph it. Remember, it's touch if it's even, and it's cross if it's odd. So at 4, the multiplicity is 1, because there's only 1. The power is 1 up here. So that's going to cross. And then it is 3 for negative 5, because that's the power, so we'll cross again. Now, since it's a degree 8, we know it's going to be some kind of parabola. And it's not flipped, because remember, the way it flips or reflects is if the leading coefficient is negative. So that's going to give me a pretty good idea of how to graph this thing. So I'm going to go out to 7. I'm going to put a dot there, and that's going to touch there, don't forget. At 4, there'll be a point, and that's going to cross. And then at negative 5, there's going to be a point, and that's going to cross as well. So since it's a parabola, it's going to start here. It's going to cross here. At some point, it's got to turn around and kind of go the other way. It's going to cross here. It's got to turn around again to get back to this intercept, and then it's going to touch but not cross, so kind of go like that. So that's kind of what this looks like. Obviously, we have no idea how low this is, how low this is. I didn't calculate this y-intercept. I could have. I could just put in 0 for all the x's. It's going to be a really, really awful negative number. It's going to be huge. But in general, this would be what we're looking for. We know it's a parabola. We can see the behavior at those intercepts and what it generally looks like. So now for end behavior, we can talk about what happens as x goes to infinity and x goes to negative infinity. So as x goes to infinity, as my x's get bigger and bigger and bigger, my graph is going up. So we say as x goes to infinity, the function is going to infinity. As we go to negative infinity, as we go left, you can see my graph also goes up. So as x goes to negative infinity, the function still goes to infinity. For parabolas, they go the same direction. For snakes, odd degree polynomial functions, they go opposite directions. Okay, let's look at number 2 where we're finding the zeros of this function. Now obviously there are 3 zeros because the degree is 3. Whatever the highest power is, that's the number of zeros you have. So first thing I do is list my possible rational zeros. So my possible rational zeros are going to be the p over q. Now p is factors of the last and q is factors of the first. So in this case it's pretty nice because q, the bottom is just factors of 1, and then the top is just factors of 35. So 1 and 35, and 7 and 5. So if I divide those, my list is 1 and 35, and 7 and 5. Now to see which one of these work out of this list, typically you can plug them all in or you can graph it. Now the graph is going to look something like this when I graph it on Desmos. And this one's kind of an odd decimal, we don't know. And this one's kind of an odd decimal, I don't know. But this one is 5. So 5 is one of our zeros. It's a nice one. It works out well. The other two are not so nice, so they're typically going to be some kind of irrational number. So once you have one that works or two that work or wherever may it works, I'll go ahead and divide those out. So I'll divide out into this polynomial. So 1, 5, 0, 0, negative 7, negative 35. So my remainder is 0. So the nice thing is we have this polynomial, which is now degree 2. So this is x squared minus 7. So to find my other two zeros, I'll just figure out when is x squared minus 7 equal to 0. So I will add, now you could do quadratic formula, but because there's no x term, you can just add 7 and take the square root. So x is plus or minus square root of 7. Now again, using quadratic formula would be fine, but because there's no x term, it's just quicker to add it, take the square root, and be done. All right, let's look at number 3. So 3 is another problem about transformations where we have this weird graph, and then I'm going to transform it through this new function. So this is just some graph, so I can see some of the points on here, negative 2, 0, negative 1, 1, 0, 0, and 1, negative 1. So these are kind of my starting points on the graph, and I'll just kind of go ahead and list those over here. And then I'll see what's going to happen when I transform it through my new graph. So if I look inside the graph, I see that I'm multiplying the x's by 2. But remember, on the inside, it's always by the reciprocal. So I'm really going to multiply the x's by 1/2. So that is going to be a horizontal compression because they're getting smaller. If it's in the inside, it's always going to be multiplied by the reciprocal. So if I multiply all these x's by half, I'll get negative 1, negative half, 0, and 1/2. Now for the y's, I have this negative sign out front, and then I have this plus 1 on the outside. So the negative is going to be obviously a vertical reflection. It's going to go over the x-axis. And then obviously the plus 1 is going to be a shift up 1. So the y will turn negative, and I will add 1 to it. So we're always just trying to get the rule for the x, which is inside, and the rules for the y's, which is everything that happens on the outside. So I'll turn 0 negative and add 1, which gives me 1. I'll turn 1 negative, which is negative 1 plus 1, which is 0. Opposite of 0 is 0 plus 1 is 1. Opposite of negative 1 is 1. 1 plus 1 is 2. So these are my new points that would transform this graph. So negative 1, 1 is here. Negative half 0 is here. 0, 1 is here. And half and 2 is here. So it's going to look something like this because it's the same basic shape. It's just been moved, right? So you can definitely see how it's been compressed. And you can see how it's been flipped, and you can see how it's been moved up 1. So just follow the rules, follow your points, and you will get your new graph. All right, here on the back, I have a graph here that we can answer some questions on. So you can see the graph is closed on both ends, closed circle here, and then kind of takes this little pattern. So the first question says, what is f of 4? So f of 4 means inside the x is 4. So if I look at my graph, this is asking where is the, if x is 4, what is the y value? So at 4, you can see the y value is 3. So f of 4 is 3. Find the domain in range of this function. So the domain is the x's. So the lowest x I see is negative 4, and it is included. And the largest x I see is 4, and it is included. For range, the lowest y I see is negative 3, and the highest y I see is 3. Now again, there's no arrows going off the page like that. That's why there's no infinities involved. There certainly could be that on your exam. It just depends on what the graph is. On what intervals is the function increasing? Remember, increasing, when we talk about this, it's x values only. So we're only going to talk about the x values where it's increasing. And we'll always use parentheses. So it's increasing in this interval, and it's increasing in this interval because it's going up. So we have -4 to -2, and then 2 to 4. Only use the x values, always use parentheses. If we were to do decreasing, it'd be between -2 and 2, but this one just asks for increasing. All right, the next one is looking like it is where does the function have a relative max? Now the relative max is here at this point, obviously, but you got to remember the difference between where and what. Where is the x value? Where is it occurring? So it's occurring at -2. And what is that relative max? The value is 1. So again, where is x and what is y when you're talking about max? It's just like with the increasing. When we talked about where is it increasing, on what intervals is increasing, well, it's happening on these x values because that's giving us our location. Finally, it says what kind of symmetry is shown. So do you see symmetry with the x-axis, y-axis, or origin? I see origin symmetry here, and we can check because remember, if we replace -x with x and -y for y, we should get the same. Well, here's 4, -3, and here's -4, -3, so it's the opposite x and y. Here's -2, 1, and here's 2, -1, opposite of x and y. So it definitely shows origin symmetry. And remember, origin symmetry means it is an odd function. Y-axis symmetry means it is a even function, and anything else would not be odd or even. Okay, last problem on this second review, we just have this piecewise function. Never going to have enough practice with this. So here we have a piecewise function, 1 plus x when x is less than 0, piece 1, or x squared when x is greater than or equal to 0, which is piece 2. So when it says f of 0, I'm looking when x is 0. So x is 0 in the second piece, so I'm going to plug that in. 0 squared is 0. For f of -3, so -3 is definitely less than 0, so that would go in piece 1. So I'll simply plug that into piece 1, 1 plus -3, which is -2. So again, we're just figuring out what piece it's in. If you look at f of 2/3, f of 2/3, 2/3 is definitely greater than or equal to 0, so it'll get plugged into the second piece where we just square it. So 2/3 squared is 4/9. So hopefully these extra questions are just some extra practice. Don't forget to look at the one, obviously, that we did in class as you prepare for the midterm.